Hello friends, in this session we are going to talk about how to calculate median for a set of data. So friends, let's first of all understand what do we mean by a median. Median actually gives us measure of the central tendency. That means it gives us a value of the observation such that almost 50% of the observations are above it and 50% of the observations are below it. So that is why it is giving us a measure of the central tendency. So now in a set of data with odd number of observations, the middle one will be the median. Say for example, we have a set of data like 1, 5, 9, 10, 15 and 17. Now, and we can add another one, say 19. So these are now 7 set of observations that we have. Now this is an odd number, so we can say the middle one, which is the fourth data, gives us the median. And when we say fourth, that means we'll first have to arrange this data in either ascending or descending order, and then we are saying the middle one will give you the median. So that clearly shows that 50%, almost 50%, that is 3 data is below it and 3 data above it. So it is giving us a central tendency. But what if we have even number of data? Say for example, we don't have this 19 and we have only 6 data. Now in this, because there is no one central observation, so what we do is we take two central observations, which is 9 and 10, and we take mean of that, which becomes 9.5. This becomes the median of the data which has 1, 5, 9, 10, 15 and 17 as the observations. So we have 6, we have even number of observations, then we take mean of the middle two data, and that is what gives the median to us. And in both these cases, odd number of observations or even number of observations, the important thing is that we need to arrange the data in ascending or descending order. Like we can't have the data written like 1, 9, 10, 5 and then 17, 15. Now if you take the middle two in this case, they will come out to be 10 and 5. If you take mean of this, that will not give you the central tendency because this is not arranged in either ascending or descending order. So now how do we find out the median of a grouped data? In case of the standard set of data, it is pretty straightforward to either take the middle value in case of odd observations or take the mean of the two middle values in case of even observations. But if we have a grouped data of the type which is given in a table where we have, say for example, marks here and number of students here. So this is in the form of a class, 20 to 30, 30 to 40 and so on, and we have number of students who say 5 and so on. So if we have this kind of a data, how do we calculate the median? Now we'll first of all add another column to it, which will have, this column will have the cumulative frequency. Now what do we mean by cumulative frequencies? We keep on adding the frequency to the previous row in the same column. So say for example, we have students with 20 to 30 marks, 5, and 30 to 40, say for example, we have 10 and so on. So we add this cumulative frequency column, this column, and we just say in the first row it'll still have 5 because there was nothing prior to that. In the second row, instead of 10, we'll add 5 to that and it becomes 15. In the third row, we'll add 15 to whatever number comes here. So that is how we'll add this column to the table. We'll identify the class. This is important. We'll identify the class whose cumulative frequency is greater than the total frequency, which is n by 2, where n being the cumulative frequency of the complete set of data, and that class is called the median class. Now this is how we are going to do it. We'll see that in a few minutes. We'll see how do we actually do that with the help of an example. So we add this cumulative frequency column to the table, and then we identify the median class. We'll see how do we do that, and then we use this formula to calculate median, which says median is equal to L plus n by 2 minus the cumulative frequency CF divided by F into H. Now let's see what are all these terms. L is the lower limit of the median class. N is the total number of observations in the data set, which means the total cumulative frequency of the complete set of data. CF is the cumulative frequency of the class just preceding the median class. F is the frequency of the median class, and H is the class size. And we use this formula to calculate the median of the grouped data. Now we're going to see how do we do that with the help of an example. So now let's take this table. Now as we said, we'll add this column to it, which we'll call cumulative frequency. Now if we see, the cumulative frequency for the first row remains 20. For the second row it becomes 20 plus 16, which becomes 36. For the third row it becomes 36 plus 40, which is 76. Then we have 76 plus 10, which is 86. 86 plus 8 gives us 94, and then 100. So coming back to the formula, which says median is equal to L plus n by 2 minus CF divided by F into H. So now we know L in this case is, now first of all let's identify the median class. Median class, if we see the complete number of set of data, it is 100. So 100 by 2 is 50. So we need to take a class whose cumulative frequency is just more than n by 2, which comes out to be 76. So that means 60 to 70 is the median class. Now this becomes the median class. Now we'll find out the value of all these parameters which are used in the median based on this class. So L becomes equal to 60 because that is the lower limit of the median class. We have n by 2 equal to n being 100. So n by 2 comes out to be 50. CF is the cumulative frequency of the class just preceding the median class. So just class preceding the median class is 50 to 60 and whose cumulative frequency is 36. So CF becomes 36. F is the frequency of the median class, which is 40. So we're saying frequency, not the cumulative frequency. So we'll take the value from the number of students column. And H, which is the class size, is 10. So now if we put these values, so we get median equal to L, which is 10, 60 plus n by 2, which is 50, minus the cumulative frequency of the class just preceding the median class, which is 36, divided by F, 40, multiplied by 10, which is the class size. So we cancel this and we get 60 plus 14 by 4, and this is nothing but 3.5, and that becomes, the median becomes 63.5. So 63.5 is the median of this set of data, which is giving us a central tendency, which means almost 50% of the data is below it and 50% of the data, almost 50% of the data is above it. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.